So here are the model answers for specimen paper 1. State one difference between a kibibyte and a kilobyte. A kibibyte has 1024 bytes, while a kilobyte has 1000 bytes. And a kibibyte has a binary prefix. It means 2 to the power 10, 2 to the power 10. A byte has a denary prefix, is 10, 10 to the power 3. Give the number of bytes in a maybe byte. So first, we have to convert maybe byte into kb So that is 1024. 1024 kb for 1 maybe byte. Then bytes, again another 1024. So 1024 into 1024 bytes is the number of bytes in a maybe byte. Complete the following binary addition. Show your working. 0 plus 1 is 1. 1 plus 1 is 1, 0. 1 is carried. You have to put it here. So, because it says show your working. Then 1 plus 1 is 1, 0. Put 0 here. Sorry, here, start again. 0 plus 1 is 1. 1 plus 1 is 1, 0. And 1 taken there, or carried. Then that 1 and this 1 is 1, 0. Again, 1 carried. 1 plus 1 is 1, 0. Again, 1 carried. 1 plus 1 is 1, 0. Plus 1 is 1, 1. So, yet another carried here. 1 plus 1 is 1, 0. 1 is carried. 1 plus 1 and 1 plus 1 is 1, 0. This 1 and this 1 is 1, 0. 1 is carried and this 1 and this 1 is 1, 0. Plus 1 is 1, 1. That is the answer. Describe the error that occurred when you added the binary numbers in part CI. The above addition gave the answer in 9 bits and the 9th bit is ignored as there are only 8 bits available. Only 8 for the register. It is called an overflow error. So the 9 bit is lost. Complete the binary subtraction. Show your working. So there are 2 methods. There are 2 methods of doing it. One is just a normal way. This one. Is the ones complement method. How do you do it? Ones complement method. You convert this, the minus 1 only, not the plus 1. Ones complement is the inversion of this. So the 2 zeros become 2 ones and the 2 ones become 2 zeros. Likewise is 0, 0, 1, 0, 0, 1, 1, 0, 1. 1, 1, 0, 1, this one. Then make it 2's complement, you add 1. That means this 1 plus 1 is 1, 0. Then 1 is carried. It comes here. Then the rest is the same. The rest is the same here. Only just add 1 here. 1 plus 1 becomes 1, 0. Then you add it. Forget about the minus sign. Then once you convert to 2's complement, then you just add it. So 1 plus 0 is 1. 1 plus 1 is 1, 0. 1 plus 1 is, sorry, 1 is carried. Then 1 plus 1 plus 1 is 1. 1, 1. 1 is put here and the carry is 1. 1 plus 1 is 1, 0. The sum is put here as 0. Then 1, 1. 1 plus 1, 1, 0. 1 is carried. 1 plus 1, 1, 0. Then this is the overflows, but then no problem. This is the answer. This is the answer. Alternatively, you can even do like this. 1 minus 0 is 1. Yeah. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 We have to carry 1 here. Then 1, 0 minus 1 is 1. Then there is 0 here. So we have to carry, borrow this also. Then 1, 0 minus 1 is 1. Then there is 0, 0, 0, 0. So the same answer you get if you just subtract. Event runs a company that books walking holidays for groups of people. She has a website that customers use to book the holidays. The website has a URL and an IPv6 address. Describe using an example the format of an IPv6 address. So an IPv6 address has a set of 8 numbers, remember, 8 numbers. In IPv4, set of 4 numbers. Here it's 8. And each number has 4 hexadecimal digits. In the IPv4 address, there's only 1 byte. 1 byte for each number. Then this one, 4 hexadecimal digits for each number. Which means how many bytes? 2 bytes. For 2 hexadecimal digits, 1 byte is needed. So for 4 hexadecimal digits, 2 bytes are needed. Each number is separated by a colon, like this. Example is given. So you have 4 marks for that. These should be hexadecimal numbers. An IP address can be static or dynamic. Describe static and dynamic IP addresses. Static IP address given to a user remains the same every time he connects to the internet. User has to pay a high price to ISP to obtain a static IP address. The dynamic, every time the user connects to the internet, his IP address will be different to the one in the previous session. It is allocated by the network operating system. If its company has a LAN that has hybrid topology, describe the characteristics of a LAN. LAN has its devices connected within a small geographical area. The user or the company owns the dedicated infrastructure. The LAN has a range of different topologies. One subnetwork connects to 4 computers and 1 server set up as a star. Describe how packets are transmitted between 2 of the computers in this. It has a header which gives the recipient's address. These packets are transmitted directly to the relevant server. Server identifies the recipient's location and delivers directly to the correct destination. The LAN has both wired and wireless connections. Ethernet cables connect the computers to the server. Identify 3 other hardware components that might be used to set up the LAN. LAN must have a network interface card, NIC. It needs a hub. A switch also can be used for the LAN. Describe how carrier sends multiple access collision detection manages collisions during data transmission. The collision occurs when 2 devices transmit signals at the same time. CSMA-CD makes the devices listen to the communication channel. Carrier sends multiple access with collision detection. If no data is being transmitted, the computer can send its data. So it listens to see whether there is any communication, that is difference in voltage. There's a current coming. If not, then it will send, otherwise it will wait. Merdad has a holiday company database that includes data about holidays, such as the location, date, duration in days. Data about the customers and the holidays they have booked. Murdad has normalized the database, which has three tables. Draw an entity relationship or ER diagram for the normalized table. So data about holidays, that is the patient, then the customer. So customers here, then holidays here, and then booking. So this says two, right? About holidays, customer. And the third one is here. They have booked. You can't have bookings in one of these. You have to have a separate one. So this is the data diagram. How? One customer can have many bookings. In January, August, and all that can have many bookings. But one booking can't have many customers. One item is unique. One booking is for one room, one day, one location, one hotel, one room, and the time or the days. So that is unique to one customer. Two people can't book this one. That's why many, this from this side, one customer to many bookings. Not the other way around. One booking can't be too many customers. Same way it's this holiday. Same holiday can have 2, 3 bookings, either by 1, 2, 3 customers, or the same customer second, third time, like that, can have many bookings. So that also one to many from this side. Complete the table to identify the primary key and foreign keys for each of the tables you identified in part A1. If the table has no foreign keys, write none. So the table name customer, primary key, obviously it's like the standard one is customer ID. Then we have to have a primary key. We have to make one if there is none. Because out of the things that are available, customer, data about the customer and the holiday. Yeah, no data is available. So usually it's a name, address, phone number, those things. So you can't have a unique way of identifying them. No need of a foreign key to access because this customer ID can be accessed. So the holiday, same way holiday ID and now. But the booking has to access both. So booking ID is the primary key of that booking. Then it has to have custom ID. So this is the foreign key. With this foreign key, it can access the customer. With this foreign key holiday ID, can have access the holiday file. Explain why the holiday database is in third normal form. All fields in each of these three tables are fully dependent on their respective primary keys. So customer on custom ID, booking on booking ID, holiday on holiday ID. So all the rest of the fields are dependent on these. These tables do not have many-to-many relationships. If there are many-to-many relationships also, then it's not in the third normal form. Here, only one-to-many. The holiday company has several members of staff. The database has 2 additional tables to store data about the staff. File staff. The 2 additional files, one is staff, which has staff ID, first name, second name, date of birth, role, salary. And the next file is schedule table. The next table is schedule, which has schedule ID, staff ID, work date, morning, afternoon. You can see that staff ID is a foreign key to access this one. Following table shows some sample data from the table schedules. There are some about 4 records, right? An SQL script to display the first name and second name of all staff members working on 22/5/2020. So select staff.first name. Staff.second name, because that's a requirement. Write an SQL script to display the first name and second name. That's all. So you select these two fields, first name and second name, then from where staff and schedule, both. From both tables, where from staff and schedule, where schedule.workdate. That is because this one. On this date, schedule.workdate equals this, only on this date. And also schedule.staff ID equals staff.staff ID. That is because when you access this one, there will be staff ID, say BC, and then how do you check? Because this has to be equal to this staff ID name and all that. Just the same staff ID. If the staff ID is equal in the staff file, then you take these two names that they have worked on this particular date. Write an SQL script to count the number of people working. There is a function also here. From schedule, where workdate equals this and morning equals 2. Only in the morning of 26/5. Question 4. A cake factory uses machines to make cakes. Complete the following descriptions of types of system. Write the correct missing term in the spaces. The factory uses a monitoring system to record data such as the monitor or such as the number of cakes being produced each hour. When the data collected from sensors are analyzed and used as feedback, it is a control system. There's no feedback, it's only a monitoring system. But since there is a feedback, it's control system. One example of this system used in the factory is to maintain a constant temperature in the ovens. It uses a temperature sensor to measure the values. Sensors only measure values. Cake mixture is mixed in a large pot. A conveyor belt moves the cake tins beneath the pot. Conveyor belt stops and a set quantity of the cake mixture fills the cake tin. Conveyor belt then moves and another cake tin is positioned beneath the pot. Then the control system. Explain how the control system will ensure the correct amount of mixture is placed in the cake tins. So, either infrared or pressure sensor will detect that the tin has come to the correct place. It has come to the correct place here. Either infrared beams from this side, that side, with a emitter and a sensor, then it will know when the beam is broken, you know that this has come here to the correct place. Or pressure sensor. There's a pressure sensor here. When it comes for the weight of it, the pressure will change. It will detect. And a signal will be sent to the microprocessor. Signal is sent to the microprocessor that it has come to the correct position. The microprocessor will send a signal to an actuator Stop the conveyor belt. So this has to be stopped. The sensors can't do anything. Sensors just send signals to the microprocessor, and the microprocessor sends a signal to stop this conveyor belt. Another signal will be sent to open the nozzle to fill the tin with cake batter. So there's another signal which will go and open this shutter here. The nozzle here is open so that it will fill the tin. A pressure sensor will continuously send the readings of the weight of the tin that is being filled currently. So the increasing reading will reach the CPU. At one point, it will decide to stop. Microprocessor will compare the weight of the tin. It's a preset value and sends a signal to an actuator to stop filling. Another signal is sent to another actuator to move the tin away. So the cycle. Cake, cake factory has servers that store its confidential recipes and control the factory machines. Describe the implications of a hacker gaining access to the cake factory's servers. The hacker can steal confidential information, including the company's secret recipes. It can cause losses to the company if it sells recipes to the company's rivals. The hacker can stop or change the way the machines work. That also can cause losses to the company. Explain how the company could protect its data against. Company can install and run a firewall which would block receiving any disallowed data. The company should keep the firewall software up to date. The company can use strong passwords. They can implement other authentication methods involving biometrics. So you make it very extremely difficult for a hacker. If they take these measures, the company can ensure. Machines have a counter to record the number of cake tins filled. Each time a cake tin is filled, the counter is increased by 1. The value is stored in an 8-bit register. The current value is shown. That is this. So now, one by one, it has increased to 9. 9 tins have been filled. Show the value of the binary number after another 5 cake tins have been filled. So another 5 means 9 plus 5 is 14. So this is 14. 8 plus 4 plus 2, 14. The following table shows some assembly language instructions for a processor which has one general purpose register, the accumulator. At the end of each day, the register is reset to 0. Write the assembly language statement to reset the register to 0. So you have, what are the operations you have? LSL and LSR. LSL is logical shift left, logical shift right. So how can you make it 0? All the bits, whatever, irrespective of the number, register to 0. If you use bitwise and 0, all bits will become 0 because 0 and 0 is 0, 1 and 0 is also 0. So whatever, irrespective of the bits, the 0 will make it 0. So that's how you reset. A two-place logical shift to the left is performed on the binary number shown in part D. The number shown in part D means not this number. Be careful. Part D, this is the one that is shown. This is not shown. This is what you wrote. So, the gap shift. When you shift this here, 1, 2, these will be empty, so you have to put zeros for that. And the answer will be this, 2 zeros in front and 2 zeros behind. State the mathematical result of a one-place logical shift to the right on a binary number. When one place logical shift to the right takes place on a binary number, it has the effect of division by 2. To calculate, we will see. We take to the right one place and then the value. The value of this is taken. Shift 1 to the right and then take the value. Again, shift right, take the value. It will show like going down half. Every time it becomes half of the previous one. Factory servers run software that makes use of artificial intelligence. Explain how the use of AI can help improve the safety and efficiency of the factory. Using AI, machines can learn from the past experience and mistakes. They can prevent the same problem occurring in the future. They can learn to predict what can happen and raise an alarm if in danger. Question 5. Draw logic circuit diagram for the logic expression. This expression. X equals not A or B or C or B and C and D. So this is the answer. Not A or B or C means first take A or B or C. A or B or A or B or C. This one. First A or B from this and C with the result of A or B. Then not. That will complete this. Not A or B or C with this not gate. And OR. That's an OR gate here for this. Then the second part is B and C and D. B, C, this AND gate and with the result. Sorry, this is D, C, yeah, C and D first. And then with the result of that, B comes in. So B or B and C and D. That also goes through this because of this OR gate. Complete the truth table for the logic expression. This. It's a separate one, nothing to do with the A XOR B. A XOR B or not A or B or C. So these are the intermediate steps. From this, you have to build up A XOR B. That is, when it is these two are equal, it's 0. When it's not equal, it's 1. This is 1. This is 1. This is 1. This is 1. And these two, because they are both 1s, 0. Then A or B or C. Can straight away take this as A or B or C. If any one is 1, then it's 1. So here there's a 1. It's 1. Here there's 1. 1. 1. Yeah, all these have 1s. Only this is the one that has no 1s. All 3 zeros. All the others have a 1. So it's 0 and the others 1s. Not A or B or C. So the opposite of this. Not 1 and all the other 0. Then what is the final one? A XOR B, that is this, or this. This or this. So 0 or 1 is 1, 0, 0, 0, 1, 1, 1, 1, 0, 1. Yeah, 0 or 0. This is 0 or 0 is 1, 0. 0 or 0 is 0. All the others except this are 1s. So that is the end of paper 1.